Alright folks, today we're going to 11.2 of the chapter, and that's going to be talking about translations on a graph. Okay, well, a translation is just a shift. So that means we're going to take this whole figure and shift it left, right, or up, down. A combination of the two can happen as well. So last time we talked about reflections, and with reflections we had the angle measures stay the same, the betweenness, so if B was between C and A, it stayed between those. Collinearity, the same side had the same letters on each picture. Distance, that side length didn't change, but this time there's one other thing that happens. Not only do we have the same size, same shape, which is what all those other things mean together, we also have the same orientation. Okay, so you'll notice the point here is at the top left of this triangle. Well, the point is still at the top left. Okay, so when we shift something, we keep the same size, same shape, and really the same direction. And that's what's different today. Now, we can describe translations in two different ways. Okay, so our original triangle here, you'll notice, let's just focus on angle B at the top here. It's at the point -3, 5. And then we've shifted down to this one. Okay, so if we look, we went to the right 1, 2, 3, 4, 5 units, and when we went down 2 units. Okay, that can be represented by saying that the triangle has been translated along the vector 5, -2. A vector is just like a ray. Remember, a ray has one point and one arrow. It gives direction. Okay, so the vector 5, 2, or 5, -2, excuse me, it'll always start at 0, but then it means 5 to the right and down 2. So the vector would look like this. It just gives the direction of the shift. Okay, you don't ever have to draw that on the picture. It just kind of tells you which way your polygon is moving. Another way to look at it is with a rule. It says the x values we add 5 to and the y values we subtract 2. Okay, so this positive meant to the right, but it also means we just add 5. If you take a -3 plus 5, well, you'll get that +2 of the image. The same thing goes for the next one. We could subtract 2. With our second point here, if we look at 5 and our image is 3, it's because 5 minus 2 is 3. So graphically, we can count our translation, or algebraically, we can add or subtract from a given point. So what we're going to do on these first ones, since we don't have a picture, is use our algebra. This says 2, specifically it's a positive, so that means we're going to add 2. And then this 1 here has a negative, so we'll subtract 2. So what I want you to do for each of these points is we're going to just write below it here. We're going to say +2. And then on the second side, we're going to subtract 1 and go straight down. So 2 plus 2 is 4. 7 minus 1 is 6. Our image point is 4, 6. Same thing on the next one. The first thing we're doing is adding 2. The second thing we're doing is subtracting 1, and we're going to go straight down. -1 plus 2 is 1. 0 minus 1 is -1. So our point is 1, -1. Last one here. Adding 2 to the first, subtracting 1 to the second. -9 plus 2 is -7, and 5 minus 1 is 4. So we're sitting at -7, +4. Okay, so that's using vector notation. The next one, with the rule here for the translation, okay, is actually going to tell you if it means plus, it'll say plus. If it says minus, that really means we're subtracting here. Okay, so x minus 2 means we take our x value and subtract 2, just like we did up there, and then y plus 4, adding 4 to the second one. So 1 minus 2 is a -1. 6 plus 4 is 10. Alright, now that you've had a little practice with that algebra, I want you to go ahead and pause the video to take care of number 5 and number 6. We're subtracting 2 and adding 4 to both of these. The first one, we get negative 2, 1. Second one there, negative 6, 13. Now we're going to go ahead and do some graphing. Okay, so at this time, I want you to make sure you have out your straight edge, your geometer, and then highlighters. We only need 2 colors today. So pause the video and grab those out for me. When we're doing these problems, we're going to have the same first step, and that's plotting the points that we're given. Okay, so first we have 1, 2. Remember, that's to the right 1 and up 2. We call D. Make sure you're labeling your letters as you go so you don't have to do it in the end. Okay, less points on your graph is going to make it easier to find out where they go. Next one is 4 to the right and 3 up. That gets an A on it. And lastly, we go 2 to the right, down 1 for our Y. Go ahead and connect those 3 points with your geometer. And then highlight it in your first color. Alright, step 2 is we're going to find the image points. Because we don't have a line of reflection here, we're skipping straight to the next thing. Now there are 2 different ways to do this. We can do it graphically or we can do it algebraically. We're going to do both just so we can see and compare our answers to make sure it comes out to the same thing. It's kind of a way to check ourselves. When it gives us this vector, remember the -3 in the first place would mean left 3, and then a -4 for the second place would mean down 4. So what we can do is take each of these points one at a time and just go to the left 3 and down 4. So that's the first method we're going to do here. Okay, so let's go to the left 3, starting with point D, since that's the first one they gave us. Okay, so D, we want to go left 3, 1, 2, 3, and then down 4, 1, 2, 3, 4, and that will be our new point, D prime. We'll do the same thing with the next 2 points. So A will go 1, 2, 3 to the left, and then 1, 2, 3, 4 down. Plot that point, which is our A prime. And finally, from Y, we're going 3 to the left and down 4. We'll go ahead and connect those. And highlight. Remember that a translation, not only are you going to see the same size and the same shape, but it should be the same orientation or direction as well. Okay, so we've taken this whole thing and shifted it down and to the left. Alright, so now that we have those points, we could write these ordered pairs using them. Okay, so you'll notice A was to the right 1, down 1. D was to the left 2, down 2. And then Y was to the left 1 and down here 1, 2, 3, 4, 5. Okay, so we can write those just by looking at the graph, or we can write them using the rule like we practiced up above. Okay, so I just quickly talked through what they were on the graph. We're going to write the algebraic way here and then just compare them to our graph to make sure we graph this okay. So remember, what you see is what you get here. If it says -3, we want to subtract 3. It says -4 next to that. And straight down. So 1 minus 3 is -2. Then 2 minus 4 is -2. Checking that on the graph, left 2, down 2, looks good. The next one, -3 minus 4. 4 minus 3 is 1. 3 minus 4 is -1. Checking that on the graph, right 1, down 1, looks good. Finally, -3 minus 4 again. 2 minus 3 is -1. 1 minus, or negative 1 minus 4 is negative 5. So left 1, down 5, our y prime is where it needs to be. The next one, we're doing the same thing. Again, step 1 is just sketching these things. So left 5, down 4, negative 6, 0, negative 2, 1, 0, negative 3. We've had a lot of practice graphing, so I want you to pause the video, plot those 4 points for me. Remember, once we plot them, we want to highlight it. That helps us see if our result ends up looking the same size, same shape very quickly there. So now, what we want to do is use the vector 5, 4 to translate this polygon. Okay, so here on the graph, we're going to take each point and go to the right 4 and up 4. So from R here, 1, 2, 3, 4, 5 to the right, 1, 2, 3, 4 up. And that is R prime. Next one, I, 1, 2, 3, 4, 5 to the right, 3, 4 up. That's I prime. Go ahead and keep counting on each of these until you have all of your points plotted. Now, if it's difficult for you to graph those when you have to move quite a bit of distance, shifting to the right 5 and up 4 is a lot to be counting. So if you struggle with that, you can find the ordered pairs first, algebraically, and then go ahead and graph those. Okay, so let's find them algebraically, and we can compare them to our graphs. So we're adding 5 and 4 to each of these. So negative 5 plus 5 is 0. Negative 4 plus 4 is 0. So once you did that, you could plot 0, 0. Okay, seeing that it's already on our graph since we graphed them first, but they check. The next one, we're adding 5, adding 4. So negative 1, 4, you could plot that if you wanted to graph it second. Negative 1, 4 checks for us. Plus 5 plus 4 on the next one gives us 3, 3, which again is on our graph, so that looks good. And finally, we've got 5, 1. Right 5 up 1, and we're done with this translation. Alright, so that was graphing with a vector given to us and with a point, or with us given points. On the back side here, instead of being given points, we're just given a picture on a graph, and we're supposed to translate it using the rule here. Okay? For these ones, since we don't have points, we're just going to graphically translate, but I want you to do this first. Find all your corners and put dots on them. We're really going to shift all of the points on there, but the main ones will help us draw the shape. So all your corners, put a dot on them. And because we translate them one at a time, I want you to also give them names. So let's call this A, B, C, D. That way we can go in order when we translate each of these points. Okay, so let's highlight the original like we have been doing. And from there, we're following this rule. It says minus 4, since that's with x, that means to the left 4. Okay, so from A is where we're starting. 1, 2, 3, 4 to the left. Then it says plus 2, so 1, 2 up. That's A prime. Same thing with B. We're going 4 to the left and 2 up. B prime. C, we're doing the same thing. 1, 2, 3, 4 to the left, 2 up. You'll notice that ended up being on our original polygon. That's okay. Sometimes translations overlap just like our reflections did. Last one here, 4 to the left and up 2 is D prime. Now, another reason we're highlighting this and labeling our corners here, our points, is so we know how to connect them so that this same shape happens. You'll notice there's a segment connecting A to B, but there's not a segment connecting D to B. So we have to make sure we're following the same shape that we saw in our original picture. So A to B was in the original, so we need to connect A prime to B prime, B to C next, then C to D, and D goes back to A. And hopefully you'll be able to tell that those are the same size, same shape. They've just been shifted up and over a little bit. Alright, same thing over here. We're going to put our points on there first. So A, B, C, D, and E. Okay. With that, I want you to pause the video, go ahead and highlight this shape, but then translate following that rule for me. You can check it when you're done. Kind of like last time, we have a little bit of overlap here. The point D was also our A prime once we shifted it over, but that's okay. We have the same size and the same shape. It's been moved to the right 5 and down 1. Last problem here, you'll notice something a little bit different about the rule. The first piece in our ordered pair here just says X. It doesn't say plus something, it doesn't say minus something. That means that X gets to stay the same. So we'll put our 3 points on here again, just like the last couple. So A, B, C. Highlight that. And then the only thing we have to do for our image is just add 4 to Y, which means shift up 4. So we're going to take each of these points and shift them up 4. So the first one, A prime. Same thing with B, up 1, 2, 3, 4. And finally with C, we've got our translation. Go ahead and connect those 3 points and highlight it to finish up there. Alright, that's all with translations. They're hopefully easier than reflections. If you do have any questions on your homework, feel free to come see me.